Hey everybody, I'm going to do a video here showing you some ways that we can transform the graphs of sine and cosine. And so yesterday, or you should have gone through and kind of done the little notes and video about what sine and cosine graphs look like. So here on the screen you can see we have a sine graph. This is just standard sine. It starts at 0. We've talked about this. It goes up to 1, crosses back at pi, goes down to -1, ends at 2 pi, and then a new curve starts. And so this, you can kind of see if I zoom out, you can see it keeps going and going. It just continually does that same pattern over and over again. And so we are going to zoom in a little bit so we can see this a little bit better. Actually, I'm going to zoom out because, well, let me stay zoomed in for now. We'll change it in just a minute. But I want to show you some things that we can do that change this graph. And so today we're going to focus on the amplitude and the frequency. And so the amplitude we'll do first. And so the amplitude is going to be what happens when we put a number out front. So you can see here I have basic sine, parent function. And the second one I have a 2 out in the front. So typically with other kinds of graphs, we know if we put a 2 out in the front of a quadratic, makes it skinnier. If we put a 2 out in front of an absolute value, it makes it skinnier. It doesn't make these skinnier, but it does change, it stretches them out, we'll say, which is also what's really happening in a quadratic and an absolute value. It's stretching those values out, which makes it look skinnier. So here it's going to stretch them out in a way as well. So let me turn that one on, and you can see when we turn on the 2 sine of x, it's this bluish purple color. I want you to take note of a couple of things. One, it starts and stops at the same place. So that does not change. Starts at 0, goes up, now it goes up to 2, comes back down and still crosses at pi, goes all the way down to -2, comes back up and still crosses at 2 pi. So the how long it takes to get from 0 to 2 pi does not change. It's going higher and lower. Okay, if we turn on the one that has a 3 in the front, let me try to zoom out for you a little bit. It goes up to 3 and down to -3, up to 3, down to -3. So that same idea, it still is going to cross the x-axis at all of the same points. Okay, we turn that one off. Now let's put a fraction out in the front, something less than 1. Look what happens when we put 0.5. Same, crosses the x-axis at all of the same points as our original function, excuse me, I have hiccups, except now it's only going up to to 1/2 and down to -1/2. And so the height of the graph is what changes. Okay, so what I want you to think about and remember, this is going to be really important in the coming lessons. The amplitude tells us how far up and how far below the sine curve will go from the very center. And so for what we've done so far, the center is the x-axis. This graph is totally centered along the x. It goes up 1, it goes down 1, or it goes up 0.5, down 0.5 from the x. So it is, but as soon, in a few days, the x-axis will not be the center. We're going to shift these graphs up and down. And so don't get into the habit of thinking that this number out front, this amplitude, tells you where it touches. It tells you how high it goes from the center. Okay, so ours is centered at the x-axis, so it's going to be its height, but eventually they might be centered at 1, or they might be centered at -2, and it tells you how high above and below it goes. So I don't want you to think in your head, the amplitude is 2, it goes up to 2. I want you to think the amplitude is 2, it goes up 2 units from where I'm starting, or it goes down 2 units from where I'm starting. Let's look at what happens when we put a negative out front. We know this. Negatives out front of graphs flip the sign, or flip the graph every time over the x-axis. This is no different. If I turn on the negative, you can see it still starts at 0, but now goes down first, still crosses at pi, goes up, and then back down to 2 pi. So it's upside down. So the flipping or the reflecting across the x-axis is true here as well, okay, for these sine functions. Okay, let's look at changing something else. Let's look at what's called the frequency. The frequency. Okay, I would like to apologize. I had to pause the video and start again because my kids came running in the room because they heard the ice cream truck and they were dying for ice cream. So I apologize for the awkwardness there and then the weird pause. Okay, so let's pick this back up. So now let's look at what's called the frequency. The frequency is also going to change the sine graphs, but in a different way. And so let's look at that. I find this actually pretty interesting. Here we have sine, and this is still the standard parent function sine curve. Look at this one right here. I'm putting a 2 inside the parentheses in front of the x. Okay, note the location. Okay, I'm going to turn that on. They're both red. I'm sorry, I don't know how to change the color, frankly. Let me actually I'm going to turn the original sine one off. The same color is confusing. Please note that for this one, it's kind of smushed. Okay, it's skinnier sort of. And so it still starts at 0. So it's still going to go up, still goes up to 1, but now it's crossing at pi over 2. What I really want you to look at is the pattern. We're going to go up, all the way down, all the way up, all the way down 2 pi. We have, between 0 and 2 pi, we have completed 2 full sine curves. This number right here inside the parentheses is going to tell you how many complete sine curves you have between 0 and 2 pi, always 0 and 2 pi. So that is going to tell you how many sine curves you get between 0 and 2 pi. So if we're starting here, everything else about it stays the same. Up, down, up, down, up. By 2 pi, we have completed 2 full sine curves. That is what the frequency tells you. It's frequent. Frequency means how often something happens. How often are we completing a sine curve? The frequency. Let's turn that one off. Let's look at 4x. This means we're going to complete 4 sine curves before we get to 2 pi. So these are really skinny. So here we start at 0. You can see 2 pi. Actually, let me zoom in a little bit, and maybe then you can see just that. We're going up, down, up. That's 1. Here's another one. Up, down, up is 2, up, all the way down and up is 3, up, all the way down and up, we get to 2 pi, and we have done it 4 times. Okay, let's take a look. Let me put that one on with regular sine so you could just see the difference there. You can see it's much more frequent. The curves are happening much more frequently. Let's look at 0.5. 0.5 means you will get half of a sine curve between 0 and 2 pi. Half. So the half is the up and the back down and touching. Here's regular sine. Half of a regular sine curve is up and down to crossing. So if you look, by the time you get to 2 pi, you've gone up and touched 2 pi, and that's it. In order to get a complete sine curve for that green graph, we have to go all the way out to 4 pi. It's taking it twice as long to get there. So the smaller number, less than 1, is going to stretch it out. A number bigger than 1 is going to smush it, because bigger number means it's happening more quickly. Smaller number means it's taking a long time to get there. Okay, let's do 1. Let me actually turn that one off. That's regular sine right there. Let me type in one more that puts an amplitude and a frequency. So let's do 2 times the sine of, oh, I don't need a parenthesis right there. 2 times the sine of 2x. Okay, and you can see it goes all the way up to 2, but it's also skinnier. So it has a height or an amplitude of 2, so 2 to negative 2, 2 units away from the center, which is 0. And the 2 right here means you get 2 complete curves before you get to 2 pi. So up, down, up, back to 2 pi, you get 2 complete curves in there. So you can have both of those things happening at the same time, and usually we do. Okay, so I do want to say I've used all sine here. The same things are true for cosine. Sine and cosine are the same exact graph, just shifted over to different starting points. So the same things are true here. A 2 or a 3 or a 0.5 in front of cosine is going to make it taller, go up higher and lower, and a number on the inside is going to tell you the frequency, how many times it occurs. So amplitude is how often or how high it goes and low it goes from the center. Frequency, how many complete sine curves you get or cosine curves you get between 0 and 2 pi. Okay, we are going to talk about this together in just a little bit.